this video, we'll discuss the vector sum and the vector difference. And we have also the normalization of vector. So, remember in our previous video, we have the unit vectors in terms of unit vectors, and we are able to convert the vector given the magnitude and direction and converted that into a unit vector. So let's recall first. So in 3 dimensions, if we have the vector on this dimension, so we have the x, y, z representing the 3-dimensional axes. Now suppose we have vector A, okay, then take note that this is lying on the 3 dimensions, so therefore we have 3 components of this vector. Now in terms of unit vector, we understand in our previous video that the unit vector assigned to x is I hat, and we have also the unit vector assigned to y-axis is j hat, and we have the unit vector assigned to z hat is z-axis is the k hat. So we have I hat, j hat, and k hat. Okay, x is I is positive towards positive x, and the j is positive towards the positive y, and with the k hat positive towards the positive z. The reverse are negative. Okay, so okay, now take note that vector A is the vector sum of its components. So it should be EX plus AY plus AZ vectors. These are the 3 components of vector A, and this is geometric sum. Okay, now remember that the components are vector also. So this is vector, vector, vector. Now if we express this in terms of its unit vector, this will becomes EX as the magnitude of the vector A along x. So this is scalar because magnitude, and this is I hat. The I hat is the vector. So if you multiply the EX by I hat, this is actually the vector EX component. Now remember that I hat is the unit vector assigned to x. So this is unit vector. The magnitude is 1. So therefore, this term has a magnitude of EX actually. Whatever value of EX will be the magnitude of the vector EX. Okay? So similarly in the y-axis, we have the AY, JY, and the z-axis AZ, we have k hat. So this is j hat, AY, j hat. So therefore, this is an expression that describes the vector A, and this is in terms of unit vector. So the question is, where is the EX, I hat, AY, J hat, and AZ, K hat graphically? Okay, look at this one. Now remember that this is AX, so therefore this is X component of A, so this should be located in the positive x-axis because this is positive I hat. Okay, so this is vector starting from the origin towards this point. And remember, this is 3 dimensions, so we have to look this figure as a box. So this is, if this is reaches to the wall of this side of the box, so therefore EX must be at this point. Now AY should be constructed from the tip, or can be constructed from the tip of the EX vector. And this is positive, so you have to move upward, so therefore this should be AY, J hat. Okay, then the EZ vector has EZ magnitude times the K hat, so this is positive, so the positive is towards us, so towards us, and this should be parallel to this line because this is the Z hat, so therefore this should be EZ K hat. So these are the graphical presentation of this vector. we have the EX I hat, AY Z hat, and AZ K hat. So it should be reaches to the tip of vector A, because remember that the vector A is the sum of the vector sum of the components. So the A vector should be the closing point from the starting point towards the end. So therefore this should be the vector sum. So this is representing mathematically, and this is graphical presentation. Both of them are the same. Okay. Now, another way to present, because this is in terms of unit vector presentation, we can also present this in terms of matrix. Okay. So we have a one column matrix. Then the first element or the upper element is the magnitude of the x component of A, and followed by the magnitude of the y component of A and the z component of. So these are the magnitudes of the components. The I hat is automatically in the first or the upper layer, and the middle and the lower. So therefore, if you look at this kind of vector, this is actually expressed in terms of unit vector, understood to be I hat, j hat, and k hat. So therefore, we can rewrite this in this form, vice versa. So any problem encountered, don't worry because they are the same. Okay, so then what will happen if you are asked to calculate the magnitude of this vector, vector A? So remember that in our previous, we understand that the magnitude is actually using the absolute sign. So it should be the absolute of vector A, then you have the square root. Remember in our previous video? The square root of this A squared plus Y squared plus Z squared, then that's the magnitude. So therefore, calculating the magnitude, you have to use this formula always. Don't forget this formula. This is how to calculate the magnitude. So therefore, all you need to do is to replace AX here, AY, AZ. Do not include the unit vectors. Why? Because remember, this is magnitude. So magnitude, there's no direction. So you have to eliminate the unit vectors. Consider only the components, the magnitudes. So we have EX, AY, AZ. Both of them should be squared in. Add that 3, then take square root, and that's the answer. Okay, so that's it. This is the magnitude of vector A. Now, suppose we have U hat. This was already discussed in our previous video. We have to recall. Suppose we have U hat. Okay, U hat. This is a unit vector. U. We call this as a unit vector of vector U. So if we have U and we have the arrowhead above, we call this as the vector U. That's why we call this as the unit vector, because this is caret or hat of vector U. The vector U is this one. So the equivalent unit vector, the unit vector of vector U is U hat. So if you are asked how much is the magnitude of vector U, again, you have to take the absolute. That's the magnitude of U. Okay. Now, if we divide the vector U, this is the vector U, by the magnitude of vector U, the answer is U hat. Okay. So therefore, we call this as the normalizing the vector. Normalizing the vector is actually finding the unit vector. So if you divide the vector U by its magnitude, the result is the unit vector. Okay, so this is normalizing a vector. It's actually the same as finding the equivalent unit vector of a given vector. So okay, so therefore the result is also a vector, because this is vector in terms, this is in terms of I hat, j hat, and k hat. This one is magnitude only, there's no one. So therefore this is actually the denominator of this vector. Then you have to simplify, then that's it. Your calculating the amount of unit vector. See. Suppose we have f, force f. Okay, 6i hat plus 2j hat minus k hat. Now, suppose you are asked how much is the, or what is the equivalent unit vector of vector, sorry, change this to f. What is the unit vector of vector f? Okay. Now, to do it is use this formula. Remember that this, okay, so this should be vector f over the its magnitude. So, absolute magnitude. This vector f is actually this one. Okay, the denominator is the magnitude. So, what is the magnitude of vector f? What is the magnitude of vector f? So, recall our previous slide. Our previous slide says that the magnitude of a is the square root of a squared plus ay plus ac. So, in this case, the magnitude of f should be what? The square root of 6 squared plus 2 squared, because this is ay. Now, without the coefficient here, understood to be 1. Okay? So, you have to square the 1. So, therefore, this is the result. The numerator is the vector f, and the denominator is the magnitude. The magnitude uses this formula. Now, one thing to remember is we ignore the algebraic sign of this, or the algebraic sign of its component. Why? Because remember, these are magnitudes. Magnitudes have no negative. Magnitudes are always positive. So you can ignore the negative here. This one is positive, so nothing to worry. You have to ignore. And this is 1. So therefore, if you include the sign, okay, you can still do it. But when you square it, it will eliminate its sign. So therefore, everything will be positive value. So all you need to do is to combine this one denominator. Okay, this is 6.40. Then you have to share the denominator. Share denominator in order to separate the components of the unit vector. So therefore, this is 6 divided 6.4, 2.6.4, then negative 1 over 6.4. Let's calculate. We have 0.938 I hat for the x component, and this is the j component, y component, and we have the z component. So you have to use the sign. So therefore, this is the unit vector of vector f. So if this is correct, remember, what is unit vector? A unit vector is a vector pointing in the direction of the vector. So therefore, this will illustrate the direction of the force F. So since this unit vector, the magnitude should be 1. So therefore, if you calculate the magnitude, if this is correct, so therefore calculating its magnitude, the answer should be very close to 1, not necessarily exactly, because we are rounding off numbers. So if we verify this one using this formula, take note, this formula, magnitude, because this should be 1, so let's do it. So verify the credibility of your answer. So the magnitude of this unit vector, take note, this is unit vector. So you have to use this unit vector, which is this one. So you have to square the x, square the y, square the z. Ignore the negative sign, then calculate. And the answer is 1.000. This is approximately 1. Okay? So therefore, this is correct. This is correct answer for the unit vector of vector A, because unit vector should have a magnitude of 1. That's it. Okay, let's proceed to the sum. Vector sum and a vector difference. When we say vector sum, it should be combining with positive. Then vector difference is you have to subtract the two vectors. Suppose I have vector A in terms of its component ay I hat ax I hat ay z hat plus az k hat. For the vector B, in terms of its component, we have bx I hat plus by j hat and bz k hat. Okay. Now, if you are asked what is the vector addition of or vector sum of these two vectors, okay. Now, remember that in our previous videos, we find the vector sum of the resultant. Now, this one, still, we are asked to find the vector sum, but this one is in terms of unit vector. So in this case, the vector sum can be easily solved by applying the uh, vector algebra, basic algebra. Okay, so to do it is you have to add vector A plus vector B. So this A is this one, and this B is this one. So you have to combine. So we have the vector A added by vector B by simply substituting these values to this one. So this positive sign is the vector symbol or the sum symbol. So you are adding vector A and vector B. Now next is you have to combine the like terms. So in algebra, the like terms can be combined. Now in vectors algebra, terms are like terms if they have the same unit vector. So you have to remove the grouping symbol, then combine the like terms. The like terms are exi hat and byi hat. Then we have ayg hat, byg hat, then azk hat, bzk hat. So you have to combine it. So combining is we have to isolate the unit vector. So this will becomes ax plus bx plus I hat, ay plus. Okay, so therefore this is the simplified form. This is actually the vector sum. Okay, so all you need to do, actually, if you're asked to find a vector sum, just add this one, add this one, add this one. This is, remember the component method. Combining all components along x, component along y. Okay, see? So you have to add this. This is actually the process of finding the vector sum. So you can notice that if the vector is in terms of unit vector, we can easily find the vector sum. Okay? So if it is easily to find the vector sum, it is also easy to find the vector difference. Now take note, in our previous videos, in our topic of finding the resultant or finding the vector sum, we did not ask the vector difference. Although we can solve, okay, but we focus on the vector sum. Now in this case, we give emphasis the vector difference or subtraction of vectors. So how to calculate? Very simple. Use the same. Instead of having plus, change it to negative. Everything are the same. So this should be subtracted by this vector. Remove the grouping symbol, so therefore this terms becomes all negative. Then combine the like terms. So the only difference is you have to change this into what? Plus, minus. Okay? So you have the minus, but this is still plus because you're collecting the negative numbers. So the difference is this is minus compared to the vector sum. So all you need to do is to simplify. That's it. You are already providing the answer. Now, the answer that involves unit vector is actually the ultimate solution of finding the answer. So, meaning to say that if you are presenting a vector and it is in terms of unit vector, everything is actually enumerated on that problem, which means that it has already the magnitude and it has already the direction because the I hat, j hat represents the direction. Okay, so let us have the example, another example of the vector sum. So suppose I have this one, I hat minus 5 I hat minus 3 j hat. This is the vector c, and vector d is negative 6 I hat plus j minus 1 hat k hat. Then vector sum. Okay, so letter A, the same. So c is 5 minus 5 hat minus 3 hat j hat, then added by, so you have to add this with this one. Then remove the grouping symbol, combine the like terms. So when you remove it, this should be 5 minus 6. So this is 5 minus 6. This one negative, this is negative. So this is negative because this is, okay. So when you remove this one, this will become plus. Okay. And this one remove, this will become 0. By the way, this is 0. Why? Because there is no k component here. So it should be 0 minus this because this is negative. So then that's it. This is negative 1, negative 3 or negative 2, and this is negative 1 half. So therefore, by the way, when you present your answer, final answer, the rule of algebra is no negative in the first term. So all you need to do is to use the sign preceding principle. You have to uh, take the common factor. The common factor is negative 1. So you have to take the negative 1 outside so that this will become positive. Take the additive inverse. So you can say that the vector sum of C and D, C plus D, is negative quantity I hat plus 2 G hat plus 1 half K hat. And this is the answer to problem letter A. Letter B, vector difference. Okay, so then change this to minus. So we have this minus, almost the same. Then remove the grouping symbol. If you remove the grouping symbol, this is minus, minus becomes plus. Algebra. Multiplying the same sign is positive. So this will become plus. So you combine this, so this will become 5 minus 5 plus 6. Okay? Okay, or you have to remove this is positive 6, and this is negative j, and this is positive 1 half. Then the like terms are this one. This will become 11, and this is 4, negative 4, and this is plus 1 half. So this is the answer. This is already the answer. This is the vector difference, while this one is the vector sum. Okay? So, therefore, if you are asked the magnitude, then you have to use the absolute symbol. Now, normalize vector, what does it mean? So, the word normalize means finding the unit vector. So, you have to find the unit vector C and D. Okay, let's do it. C, remember, normalization process formula. We have the vector C divided by its magnitude. So, the vector C is 1. And this is the magnitude 5 square plus negative 3 square. Then, simplify the denominator, then share it. So, after simplifying, divide this by this one, then minus 3 divide this one. So, the answer is 0.86 I hat minus 0.51 J hat. This is the unit vector. When you verify this one, square this one, plus square this one, take square root, then you'll arrive almost equal to 1. If this is correct. Okay. Letter D, or unit vector D. So, vector D divide its magnitude. So, this should be, replace it here. Then the magnitude is, okay, I include the sign to show that there's no such difference if you consider the positive, but negative. But next time, not use the negative sign. Okay? When you square the negative 6, it will become positive 36. Okay? 1, and this is also, so therefore, you can ignore the sign. You will arrive the same, so that your solution will not be complicated. You can ignore the sign. Okay, so therefore, share denominator, then divide 6, negative 6 by this value, then you have this negative, positive. Because remember, this will provide always a positive the magnitude. So, whatever the sign here will be the sign also of your answer. This positive, positive, negative, negative. Then, remember, if your answer is correct, this should be less than 1 number. Everything here are less than 1. If you have the answer greater than 1, it is a signal that your solution is wrong. You have to double check your solution. By the way, this is negative, so you can take it out. And this will become minus, and this is plus. That's it. This is how you present the answer. Letter D question. What is the magnitude of the vector sum of C and D? So the word magnitude means take square root. Okay? So therefore we have this one. So the magnitude of vector CD means you have this equivalent to the absolute. So you have to recall your answer in letter A. The answer is negative 1. We use the negative 1 because we are not presenting yet the answer. So use negative 1, negative I hat plus negative 2 J hat minus 1 half K hat. So this is the vector sum. Okay, then take note. Okay, then replace. Then remember the formula of finding the magnitude, square root. If the question is magnitude, then think of square root, then square its components. So therefore, you have to square. Then component of this is 1, and this is 2, and this is 1 half. So take square root. Then the answer is 2.29. This is the answer for letter D. Very simple question if you know this principle of finding the magnitude. Okay? So, that's it. Now, for your practice, I encourage to solve this one on your own. Solve this on your own idea. So, to verify how far you are from this topic. Vector sum and vector difference. I have here question, sketch the graph. So, you have to sketch the graph. So, you have to construct the box, then illustrate the L. Okay? Good luck.